Hi everyone. So today we are going to get started with our next section, which is the last section for this class, and that's going to be simulation. So I'm sorry to have to do this via Zoom, but this is going to be a really short lecture. So I'm going to quickly introduce you or reintroduce you with some concepts that you may have already been familiar with. And then I have a how-to video posted on Canvas where you can see how to do a simulation, a very short simulation in Excel. So next class, we will do a more complicated simulation where, I will be present in class and we will go over that together. So just before we get started, I just wanted to give you a heads up of what's looking ahead. So this is, as I said, this is going to be the last section, and which will end on 4/23, right? And that's our last exam. So this exam is going to be only on simulation. And we don't really have a lot of time to cover a lot of things, which means that we only have around 2 weeks to cover things. So this will be like a shortened portion. But we still do have 2 classworks and 1 homework in this section. So the first classwork is going to be next class, and this class is going to be a little bit different than the other ones in the sense that this is something that I will be doing in the class, and you will just follow along with me. So this will be more of a regular class, but at the end of the class, you will have to submit the work on Canvas to get the classwork points, okay? So so next class will be a classwork in class. All right. And after next class, I will post our next homework, which will be again due in 7 days. But again, like we will not learn a lot of new concepts in this small section. So we will only learn a few major concepts and we will do multiple problems on that concept. Okay, so let's get started. So just as I said, today I'm going to talk a little bit about the background of simulation, some important key components of simulation, what to keep in mind, and we are going to end with the first simulation model. All right, so just looking back in our lecture one, as I always look back at that whenever we are starting a new section. So we are talking about, in this course is about business analytics, right? So where we talk about a scientific process where we can transform data into some insight. And within that business analytics, we know about 3 subclasses, right? Descriptive, predictive, and prescriptive. So simulation is one of the prescriptive techniques, which means that you will not be predicting something like you did in regression or time series. You will not be predicting unknown or future data. Instead, you will be prescribing the best thing to do based on what you have seen so far or based on the data that you have. Okay, and the major difference between optimization and simulation is going to be that in simulation, you will have some deterministic inputs, meaning that some values of the input you will know for sure, whereas you will have some random input, which means that those values you will not know for sure, but you will know something like the probability distribution of those values. And we will talk more about that in a while, okay? So this is going to be one of the prescriptive analytics techniques where some of the inputs are random, meaning that you don't know exactly what the value will be, but you have an idea about the distribution of that value. In terms of complexity, really prescriptive analytics are higher in complexity than predictive because it's more powerful, because it tells you exactly what to do, okay? So again, I already explained this. So between optimization and simulation models are able to incorporate uncertainty, where optimization models, in the way that we learn them, they are not able to incorporate any uncertainty, right? So you know for sure what this something cost. You are trying to figure out, for example, in your network optimization problem, you exactly know what the costs are for all the shipping routes, and you are trying to figure out what is the optimal way to ship things, right? So there is no uncertainty in your inputs, right? Whereas here, you will see that there are some uncertainties. You might not know exactly what's going to happen. And we will keep in mind that uncertainty while we prescribe something, okay? And if you're following the book, this is going to be chapter 40. All right, so let's get into it. As I said, there's going to be some uncertainty, right? So simulation modeling is basically a method for evaluating or quantifying the impact of uncertainty and risk on a decision. So we want to understand whenever we make a decision, most of the times we won't be able to make a decision like 100% this is going to happen, right? Because there's so much uncertainty with respect to any decision that you make. For example, let's say you are planning an investment. You wouldn't know for sure what's going to happen to your investments in down the line, right? Because you don't know how the market conditions will be. You don't know how economy is going to do. You don't know if there's going to be like COVID-19 again. So there are things that you wouldn't know, right? So whenever you are making an investment decision, let's say you don't know exactly what's going to happen, which means that in making the decision, you also need to kind of understand what's the risk associated with this decision, right? So is it too risky? Is it less risky? What does my whole profile looks like? Like what is like 50% chance I'm gonna get this amount of money? 70% chance I'm gonna get this amount of money. So the whole profile. So we are gonna talk about the whole risk profile of any decision that we make now, right? Some of the marketing applications would be when there is a new product development, right? So, or let's say the timing of market entry for a product. So whenever you have a new product, you don't know exactly how the market is going to react to that, right? Which means that there are some things that are uncontrollable, right? So there is some things that are random, and based on that, you will always have a risk of either gaining some profit or losing some profit in a new product development or entering to a new market, right? And with this toolbox in our backpack, we will be kind of able to analyze this risk, okay? Some of the management applications are, for example, inventory ordering, right? So for inventory ordering, you don't know exactly what your sales is going to be, right? So sales is generally random, although you might have a very good idea what it's going to look like, but it's still going to be random because you don't know exactly how many consumers or how many customers are going to buy from you. So with that random component being in mind, you don't know exactly how many inventory you should be ordering to have the lowest cost, right? So what I'm trying to say is that in everyday decisions, everyday, not only business decisions, but even in your life decision, there's always uncertainty. And with things like simulation, we are able to deal with this uncertainty in a way that of course, we cannot say something for sure, even with simulation, but we will have a good idea of what's the probability or what's the chance of something happening, right? And that's what will help us to make a smarter decision. All right, so as I gave a hint already, we are going to be talking a lot about probabilities, right? So probability, I hope all of you have heard about probability before, or any of the classes before this. For example, the required class for this, the business analytics statistics course. So we are now going to go into depth about probability or probability distribution. So this is, I'm hopeful this is just a revisit of some of the concepts that we already familiar with. So probability is a numerical measure of the likelihood of an event occurring, right? So generally, it's measured by number of ways that a particular outcome can occur divided by the total number of ways, right? So for example, if you want to calculate the probability of a head in tossing a coin, and I say, so the probability you would be calculating of getting a head would be equal to, so it would be number of times you get a head by total number of outcomes. right? Which means, so what is the total number of outcomes? The total number of outcomes are what are the possibilities, right? Total number of possibilities. So if you're tossing a coin, there's really two possibilities. Either it's a head or it's a tail, which means the total number of outcome is going to be 2. And out of the total numbers, how many ways you can get a head, right? So that's going to be 1, right? So this is 50% probability of getting a head if you're tossing a coin. So again, I'm not gonna go into details about rules of probability and things like that, but we're gonna, of course, talk about probabilities because that's a risk measure, right? So we should be able to say what's the probability of, let's say, having a loss if you introduce this product to the market. So that's a probability. You have to figure out that this is what I'm talking about. This is the risk, right? And this is how to calculate this, right? So you will be calculating that by based on this kind of formulas, that what is the number of ways something can happen, right? Divided by the total number of outcomes. Okay, all right. So moving on, we need probability, and we will also talk about probability distributions, right? So there are certain variables we will have in our simulation model that will be random, which means that those values we will never know for sure, but we will know the probability distribution for it, right? So for example, if you want to think about a probability distribution of a coin toss, right? So you will have, we know that for a coin toss, the probability of getting a head is 50%, and probability of getting a tail is 50%. Right? So this is the probability distribution of a coin toss where a head gets like 50% and tail gets 50%. So this basically a distribution will tell you the complete picture of probabilities with possible outcomes. Right? So another example would be, let's say, a dice roll, right? So if you want to talk about probability of a distribution of a dice roll, so let's name them as D. So dice roll distribution would be 1 with probability 1/6. So there are 6 sides of a dice roll. That means for the probability of each side, getting each side is 1/6, right? So 2 with probability 1/6, with 3 with probability 1/6, 4 with probability 1/6, 5 with probability 1/6, and 6 with probability 1/6, right? So this whole thing is a probability distribution because it tells you all possible outcomes and the probabilities associated with it. Now, this is a distribution, even only if you sum up all of your probabilities, they should always sum up to be 1. Okay, so in this case, we have 6 1/6 probabilities. So if you sum them up, there will be 6 multiplied by 1/6, which would be 1. So if your probability sum equals to 1, that means that you have captured all possible outcomes that can happen, right? So this is the probability distribution. Now, we are going to have some discrete random variables and some continuous random variables, right? And then we are also going to have some discrete probability distribution and continuous probability distribution, right? So what's the difference between discrete and continuous? Discrete means that for example, a coin toss is a discrete random variable, which will have a discrete probability distribution, right? So what does discrete mean? Discrete means that it can only take particular values, right? So a coin toss can only be either head or tail. It cannot be anything in between head and tail, right? Another example would be, for example, number of daily surgeries conducted in a hospital, right? So it could only be numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, things like that. It cannot be anything between 1 and 2. Doesn't make sense, right? Similarly, age of undergraduate students at Fogelman College of Business. So your age would be something like 17, 18, 19, 20, 21, 22. It will not be something in between. So those are discrete random variables, and they will follow discrete probability distribution. Okay. In contrast, we also have continuous random variables. For example, your driving time from your house to your from campus. That's a continuous random variable because some of you might take 6 minutes and 4 seconds, right? I might take 30 minutes and 40 seconds. So it's really within an interval. As long as your value can take, your variable can take any value within an interval, that's a continuous random variable. And this will have a continuous probability distribution, okay? So example of a continuous probability distribution would look something like this, a normal distribution, which we'll talk about a lot, right? So you probably have heard about that. So a normal distribution looks like that, and this is continuous. Whereas, for example, you can have a uniform discrete distribution, which is going to be let's say the coin toss, that's a discrete distribution, right? So when it's continuous, then you will have like a continuous region to demonstrate the distribution. When it's discrete, then you will have some discrete bursts to demonstrate the distribution, okay? All right, so moving on, there are a few key components of a simulation model, and I have been giving you hints what those are, but just to sum it up, there will be two types of variables, right? There would be some variables which are certain, and the value of these variables, how do you know it's certain? Because the value of those variables, I will tell you for sure. So this is the number for this variable, right? So they're deterministic, they will never change. However, some variables will be random, which means they will be probabilistic, which means that you will know exactly what the value is going to be. However, you will know the probability distribution for it, right? So you'll know that the value will take, or the variable will take values from this particular distribution. So the first thing you will have to do in that case is you will have to generate a random variable which follows that particular distribution, okay? And again, you will see in the how-to video, I'll explain how to do that. All right. And then you will have some functions. So these functions are going to be, again, some of them will be certain functions, which means that those functions will only be like some addition, subtraction, multiplication of only certain variables. So those values of the functions will never change, yes? And then some of them will be uncertain function because they will have at least one uncertain random variable, a random variable, okay? And this first thing we will do is we will, as I said, generate the values for this uncertain random variables, okay? So we will know a probability distribution, and we will generate a random value from that probability distribution. So in simulation, I'm going to use some of the lingo, and one of the lingos I'm going to say is trial, okay? Or a simulation trial. So a simulation trial, what this really means is that doing one single simulation, okay? If I, for example, in the dice roll, right? And you will see the how-to video is also on a dice roll example. So what does, in a dice roll example, a simulation trial means just rolling the dice once, okay? So rolling the dice once and seeing what your outcome variables are, which means what did you get in the dice, that's gonna be one simulation trial, okay? Now, if we wanna roll the dice 1,000 times, right? So that means that you're replicating your first simulation trial. So that those are going to be your simulation replication, okay? So you're gonna first do one trial, and then you're gonna replicate that trial. That means you are going to roll the dice 1,000 times. Now, of course, it's gonna take a long time if you want to do it physically, and that's why we are going to do it in Excel, and we will see what this looks like or how to do that, right? So Excel will do it in a second for you. Excel will roll 1,000 dice in a second for you, basically. So let's now do our first simulation. So in the first simulation, we're gonna be traveling to Vegas, and we are going to understand what is the risk of playing this very straightforward game, where you basically roll 2 dice and you earn the sum of your 2 rolls, okay? So for example, if you roll 2 dice and your first dice is 1 and second dice is 2, you earn $3, okay? So the question I'm asking is, how much would you pay for this game? All right, so let's take a moment to think about it, and different people will have different answer for it, because people have different characteristics. And in terms of economics, some of you might be something called risk averse, which means that you don't like to take risks, right? And those people, you might have thought that I want to pay, let's say, like, I don't know, like $2, nothing more than $2, because I know for sure I'm going to get $2, right? If I roll 2 dice, I'm going to get 1, 1, 2, so I'm not going to pay more than that. Some of you might be something called risk lover, and some people might say that, okay, I'm gonna pay as high as $12 because I know I have a chance of making 6, 6, 12. So I will be, let's say not 12, but at least I'm gonna pay $11, right? And some of you might be something called risk neutral, meaning those people will be somewhere in between. They will not pay as low as $2. They will not pay as high as $11. They will maybe pay something like $5 to $6, right? So in the video that I will say, I am taking a position of a risk neutral person, okay? However, you can take a position of a risk averse person. You could also take a position of a risk lover person, okay? And it's fine either way. So whenever you answer a question, for this section, you are always going to take a position. You're going to say, okay, I'm a risk lover, which is why I'm going to do this, versus I'm a risk averse, which is why I'm going to do this, or I'm a risk neutral, which is why I'm going to do this, okay? Now, in the video, I explain how to do this model in Excel, and I will also tell as a risk neutral person what I would do, how much I would pay, okay? So after you watch that video, I have an extra credit question for you. So now I have changed the rule of game a little bit. You still roll 2 dice, but now you earn the maximum of your 2 rolls, not the sum, but the maximum of 2 rolls. Now I want you to follow the Excel simulation model that I just discussed in the how-to video, and then create a very similar simulation model with a histogram of your outputs. And once you do that, you will understand, once you watch that video, you'll understand what I mean by that. And then tell me how much would you pay for this game, okay? Now, you can be a risk lover and you can say, I'm going to pay this much. You can be a risk neutral. You can be a risk averse. So you can take either of these positions and you can say, how much would you pay for this game? But you have to answer this question in order to receive both parts, okay? So that's it. Again, watch the how-to video, and if you have any questions, feel free to reach out to me or post it in the discussion center.